right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is addition and subtraction with scientific notation. So what they're looking for is to put the numbers together and then put it in scientific notation, which you might think like, oh, well, it's already in scientific notation, so good to go, right? And no, not necessarily, because you're adding or subtracting. And when you do that, you might end up with a double digit number, or you might end up with a decimal, and then it wouldn't be in scientific notation. So you have to be careful. It also depends on, how picky your teacher is and something like that, right? But so in general, if it's in scientific notation, it is more than 1. Okay, so more than 1, but less than 10. Less than 10. Okay, so if we were going to write that in interval notation, you would say 1 comma 10, like that. Okay, because well, it's not going to be negative. You typically aren't going to deal with negatives. You could, so it's possible, like if it's a negative number. I mean, we're subtracting, so subtraction is like adding a negative. So it could be between -1 and -10 as well. But the reason why it can't be less than 1 is because numbers that are in between 0 and 1 are fractions, or like pure decimals or pure fractions is how I like to describe them. They're like 0.3, right? That's not really a one-digit number. It's kind of a one-digit number. You know what I mean? So if it's more than 1 but less than 10, and actually, you know what? More than 1 or equal to 1, actually. So I misspoke just a little bit there. We can include 1. It could be 1 equal to 1, right? Equal to or more than 1. Equal to or more than 1. So let's go ahead and do number 1. So when we're looking at these, here's how you can think about it. It would be like 3.1 x plus 4.3 x. 3.1x plus 4.3x. I can add those because they have the same x. It's not x squared. It's not 3.1y plus 4.3x. It's not anything weird like that. They're both x, and they're both 10 to the third power. So I can add the numbers. 3.1 plus 4.3. 3 and 4 make 7. 1 and 3 make 4. And when you add 3.1x and 4.3x, what do you get? You get 7.4x, right? So you get 7.4 times 10 to the third power. Okay? So you're not going to add the powers. If you multiplied the numbers, you would add the powers. But we're not multiplying. We're only adding and subtracting. So that's how that works. It's nice if they're the same power. What if they're not, though? What if they're not? Like a number 2. Okay, well, switch color a little bit here. Leaving the realm of easy problems already. Well, okay, so these tens are different tens. 10 squared is 100, by the way. So I could do one of two things, because I need the x's, quote unquote, to be the same. I could either multiply that by 10, or I can divide that by 10. And you might think like, oh, well, what? You can just do that? Like, yes and no. I mean, you can't just multiply by 10, but you know how like in an equation, so let's say I have like x plus 2 equals 3, right? So algebraically, how would you solve that? Well, you would subtract 2 on both sides, right? And then you get x is equal to 1. Okay, well, you can add, subtract, multiply, divide. You can do anything you want in an equation as long as you do it evenly to both sides. But what about an expression? X plus 2. Let's say it's just x plus 2. It's not equal to 3. I don't know what it's equal to. Just x plus 2. Could I subtract that by 2? Kind of. Because if I do this, x plus 2, all right, so I'm going to put it in parentheses here. I could subtract 2 if I also added 2. I could subtract 2 if I also added 2. And you might think like, oh, well, yeah, I guess, but how does that have to do with this, right? Well, here's what that looks like. If I times by 10, then I'd also have to divide by 10. As long as I do the opposite operation within one group of numbers, then I'm keeping that expression the same. It's just like equations, except you do one thing and do the opposite within the same realm of numbers here. So if I take 3 and divide by 10, as a decimal, that'd be 0.3. 10 times 10 is 100, or 10 squared. Okay, so I could do it that way, and then now I could put those numbers together. Or you could do it this way. You could divide by 10 for that 10, and then times by 10 for the 6.4. If I times 6.4 by 10, I get 64 times 10 to the first power. And then I could have combined 64 and 10 to the first power with 3 to the 10th power. Now, you can do either one, but let's think about it. The better one, if I combine 3 and 64, since they are both 10 to the first power, I can combine the 3 and the 64. But then I get 67, and then that's not in scientific notation, is it? So, typically what you want to do is you'll want to take the power that's the smaller of the two and make that power bigger because it makes the number smaller, and then when you add them up, it's likely that that answer will still be in scientific notation, so it's less work. So you could do either one, but it's going to be better most of the time to take the smaller power and make that bigger so that it has the same power as the other one, so that you can combine the other numbers. All right, so this is like 0.3x now plus 6.4x, which is 6.7x, or 10 squared, right? So I'm just using x as a placeholder to help simplify things a little. Okay, so that's the answer to that one. And that's the answer to that one. Okay, so let's go ahead and switch colors again. We'll switch to like a gold kind of color here, and we'll not switch as much now that we've kind of gotten a handle on what's going on. A lot of the rest of these are going to be kind of the same thing. There are negatives coming up on number 4, but that's like everything that I need to explain, I think. Let me know if there's a question that you get stuck on that you felt like I didn't explain well enough, though. So we would times this by 10 and divide that by 10. Right, so 0.557 times 10 to the 4th power. Now we add that to 2.4. All right, well, if I add it to 2.4, if you're going to do it by hand, you want to line up the decimals and do it that way. 5 and 4 make 9. 0.2 times 10 to the 4th. And there's our answer. Okay, what about negatives? Well, it still applies what I said earlier, the smaller power. Okay, well, the smaller power now is negative 3, so I times that by 10. Divide that by 10. So that's going to be 0.16 times 10 to the negative 2. Okay, and then I can combine those. So now it's going to be 5.16 times 10 to the negative 2 power. Okay, not that much different, really. All right, this one right here, I believe that's a 1. Let me make sure. Yeah, that's a 1. Okay. Just wanted to make sure I was doing it right. How you guys doing today? You guys doing good? Let me know in the comments below if you guys are doing good. All right, so this time it's going to be a few more factors of 10. Well, we can times by 10 to the third power. We would just divide by 10 to the third power here. Oh, what does that mean? Well, if you times by 10, you move the decimal place once to the right. If you divide by 10, you move the decimal place once to the left. So if we're going to divide by 10 to the third power, we're going to move the decimal place 3 spaces to the left. 1, 2, 3. So that would be 0.0025 times 10 to the fourth. Okay, so when I combine that with that, I have 6.1425 times 10 to the fourth power. Okay, the power of 10 tells you how many spaces or how many decimal places you're going to move. And if you're dividing or multiplying by 1 over 10 to a power, you move it left. It's getting smaller. And if you times it by 10 to a power, then you move it to the right. Okay, the lesser one is the 5. So I'm going to times it by 10 to the fourth power. That'll make it -1. Divide by 10 to the fourth power. Okay, so I'm going to move it 4 spaces to the left. That's 1 space to get past the 6, and then 3 zeros. 1, 2, 3 zeros, and then it had to get past the 6. Okay, times 10 to the -1 power, and then those combine, and I get 7.00064 times 10 to the -1 power. And there we go. There's the answer to that. Not so bad now, right? Okay, let's move to orange. So with the lesser one is the 6, we want to do 10 to the third and divide by 10 to the third. Okay, so 3 spaces, but if it's in scientific notation, then you'll have 1 less number of zeros than you do the power. That's the faster way to do it, maybe. So it's going to be 0.0033 times 10 to the -3. Now I can combine these, and I have 5. Oh, did I have any minuses, by the way? I wasn't really checking for minuses. Forgot to look for minuses. I was just assuming all of these are plus. They have all been plus so far, but we're coming up on some minuses in a second here. So 5 plus that, so 5.0033 times 10 to the -3. Okay, now let's do it a little bit quicker. So this is going to have to times by 10 to the fourth. Okay, I'm just going to write 10 to the fourth this time, because that's what's going to make it into 10 to the third, right? Then this would have to go back 4 spaces, right? If it's just 8, the decimal place is immediately to the right of the number. If you don't see the decimal, it's immediately to the right of the last digit. Okay, so 3 spaces, 4 spaces, right, 10 to the fourth. So 4 spaces, 3 zeros, 1, 2, 3 zeros. Okay, and then we put those together. So 6.9008, 10 to the third, and et voila. Okay, now we're subtracting. So now it's going to be just a little bit harder. So we're going to times by 10 to the third power. Because, and the other reason that I didn't explain earlier as to how I'm coming up with these powers of 10 is because when you multiply powers, you add their exponents. If I'm going to multiply by 10 to the third power, it is 10 squared times 10 to the third power. It is a times problem, but you can add the powers, and that's faster. You could multiply them, but you would want to write them out. It'd be like 100 times 1,000, right? So you could do it that way, 100 times 1,000, because that's what that is. But it's faster if you add the powers. 2 plus 3 is 5. I need a power of 5. So basically what I'm doing is I'm taking the largest power and I'm subtracting the smallest power. That's what I'm doing. And that's how I'm coming up with that number. So take the largest power, subtract the smallest power, and that's the power that you need to multiply by. Okay, 10 to the third. So that's going to have 2 zeros, 0, 0, 4. Okay. the 5th. And we're going to subtract this time. Okay, so we're subtracting 1.39. Now this is a little different because now I'm not just putting numbers together. I'm going to have to subtract, and it's 0 minus 4 is the first thing up. 0 minus 4, I can't do that, right? So I have to borrow. So then this would actually be 10 minus 4 is 6. That would make that an 8. 8 minus 0 is 8. 3 minus 0 is 3. And there we go. That got just a little bit harder that time. Okay, just be really careful when you're subtracting your decimals. Line them up with the decimals right above one another, and you should be good. Of course, if you can use a calculator, then do that too, but I'm assuming that you would not be able to use a calculator on this. So that's the larger one. -1 minus -4 would actually be 3, so I want to multiply by 10 to the third. 10 to the third. So that's going to be dividing by that, right? So it's going to move over, and I'm going to have point. Let me move that down a little bit, actually. Do this off to the right-hand side over here. So I'm going to have, because I know I'm subtracting. If I know I'm subtracting, I want to get ready to set it up. So 0.00653 and 2.74. 2.74. Okay, because that is going to be 10 to the -1 power now, right? So what is that going to be? Well, 0, 0, 0. I'm going to have to do a lot of borrowing here. So basically, when you borrow from here, you have to borrow from here, you have to borrow from here, you borrow from here, that's a 3 now. That's 10, but then I'm borrowing to make, so that's 9, and then that's 10, and then I borrow to make this 10. It's really, really annoying when you do this method of subtraction on a problem like this, but that's kind of what's happening if you were to do this method. You can do it in calculator, or I can show you another method, but I might stick with this and then just not kind of show those in between steps because it makes it look kind of more confusing than it really needs to be, I think. 10 minus 3 is 7. 9 minus 5 is 4. 9 minus 6 is 3. 3 minus 0 is 3. 7 minus 0 is 7. And then 2 minus 0. Okay, so it's all of that times 10 to the -1 power. Whew. Okay, that one was pretty gnarly, actually. These are getting harder. All right, next 4. And then we're done. Look at that. Wow. Crazy. Okay, so we're going to subtract again. We need this to be times by 10 to the third. 10 to the third. So we know we're going to have 8.14 minus, this is going to be 2 decimal places, right? So I'm going to have 2 zeros, 0.0078, dividing by 10 to the third, and I'm subtracting these, minus 0, 0. The other way to do this would be to like compartmentalize. So this is kind of like 400. 400 minus 70, and then 400 minus 8. You can kind of do it that way as well, but I don't know. I don't think I'm going to do another method for subtraction because it could be that you are allowed to use a calculator anyways, and then I'd just be kind of wasting your time. So this is going to be 10 minus 8 is 2. 9 minus 7 is 2. 3 minus 0 is 3. 1 minus 0 is 1. 8 minus 0 is 8. All of that times 10 times 10 to the 5th power. Okie dokie. So then this one is going to be, let's see, I'm going to times by 10 to the 4th power. So then this is going to be 6.36 minus, I'm going to be dividing by 10 to the 4th here, right? So 3 zeros. 1, 2, 3 zeros. 5, 8. 0, 0, 0. So that's going to be a 2. 9 minus 5 is 4. 9 minus 0 is 9. 5 minus 0 is 5. 3 minus 0 is 3. And then 6. Okay. All of that times 10 to the 3rd power. And actually, let me not box that just yet because I need to be able to see the last couple problems here. Or the number 14. Okay, so actually let's go ahead and do number 14 first, and then that way we can go back to number 13. Number 13 is addition, actually, so we'll end on an easier one. So this is going to be, we want to multiply by 10 to the 5th power, 10 to the 5th power. So I'm going to have 4 zeros, not including the leading 0. You don't have to include the leading 0. So actually, let me move that down a little bit. So I'm going to have 0 point, and that was 5, 10 to the 5th. So I'm going to have 4 zeros, 1, 2, 3, 4, 5, 9. Okay, subtracted. Subtracted into. Oh, interesting. I'm subtracting that into this other number. Huh. Okay, so that's why that's one of the last problems. Okay, so let me rewrite this over here. 0.000059. Okay, and then I'm subtracting point 0.078. Okay, so 0.078 is larger than 0.000059. Therefore, I'm gonna really want to subtract it the other way after all, but I need to remember that my answer is going to be negative. So it's going to make more sense to subtract them the way I was originally going to do it, but I just need to remember that my answer is going to be negative. Okay? So this is actually the positive. I'm going to put the other one on top of it though. I'm going to do 0.078. 000. And I'm going to subtract it this way with the larger number on the top, but I need to remember that my answer is going to be negative, right? So that's going to be 1, 10 minus 9 is 1, 9 minus 5 is 4, 9 minus 0 is 9, 8 minus 0 is 8, or sorry, actually that's going to be a 7. That's going to be a 7, because I had to borrow. 7 minus 0 is 7, 0, 0, 0, 0. Okay, but that's going to be negative because actually this right here is the negative, this is the positive. Okay, so my answer is going to be negative actually, times 10 to the 3rd power. That was actually kind of tricky. Okay, and now I can box this other one over here too. It's kind of a bad box, but it is what it is. Okay, we want to make this into 10 to the 4th, so I need to multiply by 10 to the 5th. 10 to the 5th. So I'm going to have 4 zeros. 1, 2, 3, 4, 5, 1. Add that to 0.38. Oh, this is nice again. Look at that. It's so much nicer when you can add. 0.0051 times 10 to the 4th power. And we're done. So that is it. The only thing they didn't really do here that I kind of wish they would have done is when you add two numbers and then it gives you a number that is more than 10. Like if I did like 5 times 10 to the 4th. Let me just write it real quick. So this is a bonus one that's not on this worksheet. Okay? This is something they didn't do, but I wish they would have. Okay, so I'm going to do this off to the side right here. Let's say we wanted to do 5 times 10 to the 6th plus 6 times 10 to the 6th. Okay, just a simple example real quick here. A little bonus. Well, they're already 10 to the 6th, both of them are, so we just add them up. But 5 plus 6 is 11. And now this is not in scientific notation. We didn't really have to deal with that particular kind of problem, did we? Here's what you do. You treat it just like earlier when we were like unscientificing it. It's not a word. So when it's not in scientific, you have to make it in scientific, right? 11 is a 2-digit number. That first number has to be a 1-digit number, so I'd have to divide by 10. If I take 11 and I divide by 10, it becomes 1.1. I move the decimal place 1 space to the left. Remember, you can do that if you also multiply the other number by 10. If I multiply that by 10, it would be 10 to the 7th power. And that should make sense. If you add two numbers that have 6 zeros on the end of them, but it makes a 2-digit number, then it should be a number that's a little bit larger, right? By another factor of 10. So then that would be the answer to that, okay? So watch out for that. If that happens to you, then watch out for that. We pretty much only dealt with what happens when you're trying to add numbers with different powers. If the numbers have the same powers, then you add them, and then you would normally just be done, except if you get a 2-digit number, you have to change it back into scientific notation. Okay? Awesome. So here are the answers. I have the answers as well. If I missed any of them, let me know. I don't think I did. I'm not going to check because I feel pretty confident in my abilities here. But if I did, let me know. It's possible that I messed something up. I'm not perfect. And of course, if you want some more resources like this video, like this worksheet, I save all of these worksheets with all my work on them. So if you want that, let me know. All kinds of that kind of stuff, right? So just let me know if you need any of that stuff. It should be on my website, Myers Mathematics, but if not, let me know, or if you can't find it. And that's in the description below as well, myersmathematics.com. Go check that out. I have a awesome free guide called The 5 Math Mistakes Everyone Makes and How to Avoid Them. So go check it out, see what you think, let me know what you think, and I'll see you in another video real soon.